Hello, Eric here, and welcome to my first ever devlog for my yet untitled space game.
See what you can do.
Here's a preview of things to come. A little bit of background first. I'm new to game development, if you don't count 11-year-old me struggling through coding a fishing minigame into RPG Maker 2K3. I have a deep interest in sci-fi and space operas in particular. This will be important later. I like to write science fiction and code in my free time, and I'm actually a front-end software engineer by day. I set out to build a game with the skills I currently had and to learn new skills along the way. The game I plan to build will hopefully serve as a fully featured proof of concept. My plan when I finished and got it into the hands of people to play test is to use that proof of concept to inform whether I should invest time into porting its concept over to Godot or Unity or whatever. In the meantime, I am keenly aware how silly it is to develop a game like this in JavaScript. Now, what is the game? Well, if you're familiar at all with how space combat works in video games and movies, currently you either get it in one or both of two flavors. Naval battles in space with two large ships parked next to each other, lazily maneuvering around, or dogfighting in space. Neither of these make much sense, apart from the obvious easing technical limitations to develop, or perhaps simplifying the concepts to potential viewers and players. But they still don't make sense in how objects in motion in space should behave. There are tons of good representations of how space combat can or should work. The Expanse novels get pretty close when it comes to the forces exerted on human bodies during burns, but my favorite example is in the Lost Fleet series of books by Jack Campbell. In the Lost Fleet, ships are flying so fast past each other at the time of engagement at speeds and time slices that human brains cannot hope to react in, that all of what the crews of those ships can do is plan up until that last second before shit hits the fan. The captains of those ships can input trajectories, formations of their fleets, discuss ammunition rationing, and then finally, after the moment of flyby happens, they can assess the damage and reassess the next steps as they bring their remaining ships back around for another flyby. That's what I hope to recreate here, a game that does just that. And that brings me back to what we have here. This is my game, still in its very early stages. I'll probably go into the technical details of it in a future video. Let me know in the comments if that's something that you'd be interested in seeing, but for now, I'd like to stick to the what and the why of the game.
Your plan's always this vague?
This is about average.
In a previous failed iteration of an attempt at coding this game, I had worked up a bunch of planets and moons, each in their own groups for their local little clusters. Each moon would then orbit their respective parent world in an ellipse, each cluster orbiting the central star. But as I tried to integrate the fleets, the central linchpin of this whole thing, that's where everything began to fall apart. Ships could navigate and intercept one another by referencing their own navigational computer that kept a record of what it saw in the star system in the form of a sort of LiDAR using raycasting. But the problem occurred after the two groups of ships met up. What would the math say about how they should continue their movements? I'm sure there was a way to fake it, and for sure this attempt had many other problems besides that, but that problem was what made me rethink doing the whole thing. Fast forward a whole year was when I stumbled across the concept that might just do the trick. An algorithm called the Barnes Hut simulation. I'm not going to go in the weeds too far with this one, but the gist is that instead of creating this faked ellipses to track the orbits of each of my celestial bodies, the Barnes Hut algorithm, acting in three-dimensional space as an n-body simulation, and as in the number of bodies, this algorithm recursively divides the number of bodies into groups by storing them in an octree. Each node in this tree then represents a region of three-dimensional space. The tree keeps growing and subdividing until each subdivision contains 0 or 1 bodies. Then, in order to calculate the net force on a particular body, the nodes of the tree are traversed. After all said and done, this allows our simulation to output an updated position, velocities, accelerations for every body of the simulation, including fleets. This way, by using Barnes Hut, we get the movements of the fleets for free. Here you can see a fleet, don't laugh at my placeholder cube, in a stable orbit around Earth. In both the game universe and in my day job, terminals or command line interfaces are a huge part. That's why I've decided to include one within the game itself. In the game, you sit in the admiral's or captain's seat, whoever is in charge of all fleets in the system at the time. A quick aside, while you can see Earth and the rest of Sol's system in the game currently, I'm only using them to prove out the engine. In the finished game, you can expect at least a dozen other systems, of which Sol will not be one. As the captain, the terminal will give you direct access to anything the heads-up display of the fleets and the current simulation is capable of from your perspective. The grid can be toggled with this command here, while you can jump between celestial objects like so. You can also pause, resume, speed up, or slow down the simulation. As the game develops, more commands will be added. I have designed it so that any and all functions of the game, in fact, must flow through the terminal, which is evident when clicking on elements in the heads-up display. Currently, the only way to navigate your fleets around the system you can use the terminal to increase or decrease the thrust with an attached duration in milliseconds of simulation time. This adds the navigation to an action queue that will be executed within the Barnes Hut simulation layer. As you might be seeing already, this is very difficult for a player to actually navigate with any sense of direction or be any fun at all. That's where our next enhancement comes in. I shouldn't expect players to maneuver clusters of starships around without informing them in some way of the steps to do that. Enter the navcom. Your fleet's navigational computer will be able to take data on the movements of bodies currently in the star system and translate that into a list of executable navigate actions that a terminal can add to the queue. This part is still very much under development, but I feel like I'm getting close. What I do have so far is this is the influence map data that will be fed to your navcom and the enemies. It represents clusters of regions of gravitational influence. A negative value in each cube represents a deeper gravitational well, whereas empty space, where gravitational influence is effectively zero, the simulation shows them as empty. In the future, the influence map will also use positive values to indicate hazards. One thing that I'm still playing around with is increasing the resolution of the influence map, making each cube smaller and more accurate. But that's a balancing act with the performance. I'm trying to aim for about 40 to 60 FPS, since this is effectively a browser-based game after all. The job then of the navcom is to connect the clusters and navigate within them, using whatever pathfinding and trajectory plotting algorithm that you wish. You heard that right. Although the game will come preloaded with the base navcom, you as a player will be able to write and deploy your own navcom with which to optimize and beat your enemies. Or maybe we can get some community-made AIs to bump this up a notch. Also note that the influence map data given to your fleets is offset by light delay. This means that the more distant an object is to your fleet's current positions, the further back in time you would be seeing them. The portability of the navcom is due to it being loaded into the game via a web worker. I've written the basic navcom in JavaScript using the A-star pathfinding algorithm and another function to translate into a series of orbital trajectories. There's no reason you can't write whatever you want in whatever language you want, be it Rust, C++, etc., as long as it compiles to JavaScript or WebAssembly that the game can then import. Hopefully I can show that process in a future video. As you can see, it's also still very much a work in progress. As a captain, you identify your enemy, you plot your trajectory, the time to intercept ticks down to 0, then what? Your carefully laid out formations of ships within your fleet passes directly through the formation of your enemy's fleet in a few microseconds as they sail past each other at a significant factor of c. This part is still in the planning stages, but what I think the execution of this will look like is you pre-plan your fleet's formations within a 3D cube. Your fleet then moves through the system as one object in the game world. When the time to intercept happens and the engagement occurs, a special event window opens showing what, to the human eye, would be a replay of the carnage. In the replay, you will see a physics-based simulation, possibly using Rapier.js, that shows the two groups of ships, missiles, rocks, and other objects or weapons meeting, colliding, narrowly missing, and tearing into each other. After the engagement is over, a battle report will be issued to both sides, and choices will need to be made whether to break off and lick your wounds, or to circle back around for another run until the last ship remains. That's it. That's the game.
I knew there was a reason I liked you.
I have plans to add additional things like orbital telemetry sensors to aid in reducing the offset of light delay, and perhaps ship components and upgrades that would make owning certain classes of ships beneficial or detrimental. Also, integrating story elements would be a high priority of mine, especially because of the final thing I want to talk about today. Since this is the first time any of you will have gotten to know me, I have a deep love for space operas. See, I told you that would come up later. As such, the game itself will be given the space opera treatment, with character points of view and interweaving story arcs. The universe the game will be set in is shared with my novel series that I have been working on in self-publishing as both written chapters and as a podcast on my alt channel Obsidian Gods. I want to keep this current channel strictly about topics that directly influence the game, and while the story does, I don't want it to come across like I'm constantly plugging my book. It is free though if you do want to check it out. No? Okay, moving on. The story will be set in an interim period within the human world's region of space, where the Terran sovereignty brushes up against the forces of the Herd Federation, the alien Kisavar Dominion, and the vaster Trade Collegiate, the research ships of Saturnus concern and development, pirates from Births Unknown, and the shadowy agents of Dusk. One of the playable captains will be a young Karam Ashok as he navigates his early military career under the shadow of his more notable grandmother, Admiral Satyakar. I'm still playing around with the format for how these characters will appear in the world, whether it's full character art as stills, free rigged characters, or just avatars that appear in a separate window of your heads-up display. I also plan to write all the dialogue myself and may or may not choose to hire voice actors for the various parts. Any and all suggestions for what you'd like to see, you can drop in the comments, or you can find me in one of the social media links in the description below. That's everything I've got for now. Thanks for watching.